Hi, I'm Lars. Welcome back to the C# workshop. This video we're going to talk about loops. After all, loops are just structured conditionals. If you want to know who's credited for the very first loop, stick around and find out. Let's get to it. Just like the last video, this video will get you the information that is needed to learn C#. In order to get the most out of these videos, I recommend watching them in their intended order. There will be deep dive videos after the course. There are 4 looping constructs: the for loop, the while loop, the do while loop, and we will discuss the 4th one, the for each, during the generics video. The basis of any loop is it has to have an initial value, an exit condition, and an incrementer, or the incrementer could be a decrementer. The initial value, exit conditional, and incrementer all hold different locations in each loop. As you can see for the for loop, all 3 are part of the very first line. The while loop and the do while loop set the initial value before the loop begins. They both increment during the loop. The difference between them is the while checks the exit conditional before starting the loop, and the do while checks the exit conditional at the end of the loop. The current standard rules for each of the loops are as follows. A for loop, a known amount of iterations. The condition normally uses the required incrementer. The while loop, this could be an unknown amount to iterate. The conditional could be a flag or a status or a date. And the do while is the same as the while, except for it will execute at least one. When we're going to talk about loops, we're going to talk about them individually. And the first one we're going to talk about is a for loop. And I'm just going to pop one of these guys in here. So these are typically done with the known amount of iterations, and I'm going to say typically because that's not always the case. The way these work is best to see during a debug. So I'm going to put a breakpoint here, and I'm going to execute this. Now, as you will see, the breakpoint stopped on this part of the for loop, not the entire for loop, because this is the first thing that's going to execute. So from here, I'm going to hit F11, and that's going to check to see if this count, this initial value, is less than the max or less than the conditional, the exit conditional. Then we're going to execute the operation, and this is only one line, but you could have this very, very complex code in here if you needed to. When you get done with the end of that loop, that iteration, when you get done with the iteration of the loop, then you will come over here to the count and increment. Now, like I said before, this could be a decrementer too. And then you're going to check the count to see if it's less than 5. You're going to check the exit conditional. And then you're going to go through the next iteration. You're going to increment next iteration. Increment next iteration. Increment next iteration. And then once the count or the exit conditional is met, so the count is equal to 5 at this point in time, and you will see this down here that we have 0, 1, 2, 3, 4 in the output because the count is equal to 5 and the conditional happens before the for loop. The next looping construct I want to talk about is the while loop. And this could have an unknown amount to iterate. The conditional could be a flag or it could be a status. I'm just using an integer, and we're just going to stick to the same pattern so that you can see the differences between the for loop and the while loop. Let's run this in debug mode just like we did the for loop. So this is the debug statement. Here we're going to set the initial value. Then we're going to check the exit condition. Now the differences between a while loop and the for loop is that this is the iteration, okay, of the while loop. 1 iteration, 2 iteration, 3 iterations. It's how many times you're going through. The difference between the while loop and the for loop is the iteration in the while loop actually has the incrementer. The other difference is you can do this incrementation during the while loop multiple places. Typically, you don't do that in a for loop, and you don't want to do that in a for loop because you could confuse other people that are maintaining the code. So as you can see, we got 0 through 1 through 4 here, just like we did with the for loop. Now, we will get into more complex things with the while loop. I'm just trying to show you the similarities between each of these different types of loops. And the last loop we're going to go over is the do while loop. This will act exactly like the while loop, except it will run through one time. Okay, now we kind of talked about that a minute ago, but the thing is, when we run this through the debugger, the first thing that happens is we do the initial value, just like the other two loops. They work the same. The difference is, if you notice, we are going right into the iteration statement here. And just like the while loop, the incrementer is within the iteration. So we're going to count, increment, and then we're going to check the exit condition. So like I said, the do while loop will execute at least one time. These were really big in gaming consoles, okay? So this is why this is called the game loop, because it has to execute one time or until somebody like presses X or something like that to get out of the gaming loop. So it's got to be displayed and then it's waiting. And I will show you one of those during the next few videos. Hey, if you think there's too much information to remember, then like and subscribe to the channel. Then you'll have a URL that you can go back and look at anytime. In the 70s, I used to program in a language called B, and then it went to C. In B, there were no looping constructs like the ones I just showed you. All we had back then was labels and go-tos, and that's what we made looping structures out of. It was something that would execute statements over and over again, and that's what we were looking for. This is the code that I used in B translated into C#. So I wanted to put this out here because not a lot of people ever really think about how these loops work. And once you understand them, you start seeing things that you didn't think about before. The top one here is the for loop. And as you can see, we instantiate or set the initial value, and then we put a label for loop. And the way that the labels work, as you can see, this is highlighting. When it finds the go-to, it will go back up to that loop and it will just keep on running this pattern. And the only way we get out of it is when the count is 5 or greater. Okay? So if you compare the one for the for loop and the while loop and the do while loop, they are all constructed pretty much the same way. I mean, if you looked at this loop here, the for loop and the while loop, they're 100% identical. The big difference between them is in the do while, the right line is before the if statement for the conditional. That is really the only difference that we have. Something I want everyone to take note of, and that is that these loops are for reference only. Due to the fact that in the 70s they were extremely prone to error just because their lack of formal structure. And it had nothing to do with, someone would write them and then you'd have people that were maintaining them. It had to do with that every single company and every single person that was writing these was writing them different. Okay, they were using different variables. They were using different structures. Like some people might call out into a method to do their stuff. When C came along after B, they took the concepts of what everybody was doing and they said, wow, we could make these into their own 3 special loops. So there were a lot more loops, a lot more than just the for, which was for a known amount of iterations, and the while that it would be an unknown amount of how much to iterate, and for the do while was still unknown amount how many times you're going to iterate it, but it would iterate at least one time. So there were a couple different variations that you have. Now, the new standards that we have today for while, and do while, they take care of all of the different patterns that we have, and people took a while to figure out what these patterns were and document them. And there's a lot of people that talk to each other about coding back in the 70s. Nowadays, companies don't really share information on what they're doing. One thing that I really want to cover, because it's the bane of everybody's existence as a developer, especially when you're first starting to develop. And I'm going to drop a while loop in here, and this can be done with every single loop that you have. You can do this in a for loop, you can do this in a do while, you can do this in a while, or any kind of looping that you do. Somewhere along the way, you're going to forget to put your iterator in. Okay, you can do this in a for loop too. Don't get me wrong. Even though they said, this looks like it's pretty structured up here like this, you can definitely write a for loop that looks just like this. All right. You can leave the initial value out, you can leave the condition out, you can leave the iterator out. Not a problem with that. Now, that would be identical to putting just a while true in here, and then you have to break out on your own. You're going to determine when you're going to break out. But if you put a while true in here, that would make this while statement like a do while. Back to the point is, if you leave the iterator out, this will continue to run forever. And I'm going to put a little breakpoint here, hit the F5, and then you're going to watch this over here. We're going to go down, and the problem is that the count will always be 0. And if I just let this thing run, I don't know how many times it's run. All right, but there is a lot of zeros here. I mean, we're talking pages and pages of zeros. A lot of times this is a huge problem, especially if during the while loop you're bringing things into memory and you're not getting rid of them. Like you're loading up something for something to go someplace, and you only can do this for so many of the count, or for so much, and then you'll come back and you'll do it again and again and again. You could run out of memory on the entire machine. But for a managed code system, we have our application domain that I talked about in the first videos. Okay, so there is the application domain, and that's only allocated so much memory. So you're not going to take down a machine, but you will blow up your application. It will be pulled out of memory. So these are just something that I really want you to, take note of and hold on to. What I want to talk about for the last portion of this video is nested loops. Now, nested loops usually are confusing for people. If you stick to a pattern, they will not be too bad. We will revisit these when we get to arrays, lists, and everything else. I guarantee we're going to be coming back to these things, all right? Because these are something that is very fundamentally foundational for a computer scientist to know, or just a coder. If you're just out here banging code, you want to do it, but nested loops are very important. So you know what a loop looks like, right? It looks like this. There's an I. We're just going to kick out I and then the value I. So we should see I colon 0, 1, and 2. So let's run this. And there is I colon 0, colon 1, and colon 2. Just like I said, right? That's not unexpected. So a nested loop is a loop within a loop. Now this could be a while loop. 90% of the time it's not. And this here is what I'm going to call my outer variable. When you do anything with loops, I would always use variables I, j, and k. Now the reason I do is because I refers to my outer variable, j is my middle variable. K would be the next one down. So that would be inside of this. I would be taking this and putting it inside of here, like that. And this here would become K, like this. Now, this is, great, but I'm not going to go this deep right now. But this is what I would call my inner variable. And when you have a bunch more code in here besides these consoles, whenever you're using J or I, and I can be used anywhere inside of these two, this one and this one, braces. And I'm going to turn something on here by going to options, going down to text editor, general, and then down to display, which is about halfway down, and click enable brace pair colorization and hit OK. Now you'll see braces are colored. So this is one scope. Inside of this, everything inside of here has knowledge of int I. If I had a variable out here of int h and it was equal to 5, I could use h anywhere below here, including inside of all these for loops. The j is known anywhere inside of here. The k is known anywhere inside of here. So for instance, if I wanted to put, a j here, like that, and then a k, I could do that, and we could put jk here. I don't want to do that, but I'm just saying you could. You could put ijk here if you wanted to. And I highly recommend going in and playing around with this. So let me get rid of the k, that, so we can work on this very simplistically. Now, I is the same. It didn't do anything different. It's still doing exactly what it did before, and that's I colon 0, I colon 1, I colon 2. The difference is we added something to the iterator. All right, we added this to print out J, and it's printing J0 and J1 because this is a 2. If it was a 3, we would get 0, 1, 2. Just like we're doing with the I. There'd be 0, J0, J1, J2. But we've only got J0 and J1. Okay? So let's step through this. Let me get rid of the IH up here. One line at a time. And the only way to do this is to step through it with the F11 key. So you're getting I. And so here's your locals down here. So here's a local I. It tells you that this is 0. And then you're going to pick up more. I don't really like that view, so I'm going to go to the watch and I'm going to take in I and J, and so I can watch my I's and J's. So then you'll see J gets printed, and then it gets incremented to 1. Okay. So if you look at your output, if you have another screen, drag it off to another screen, or just watch what this is doing. I can't put it on another screen. So I is 0, J is equal to 0, because we haven't got to the printing part here. You get to here. I is 1, so you're going to print it, and then you're going to increment. Now I is going to equal 2, and it's going to jump out of that for loop because it can't go any further. And there's your I, J0, J1. And you go back up to here, and you're incremented your I to 1, and then you're going to print out I is 1. And that's what we did. And this keeps on going with the J. It prints out J is 0, and it increments J. And it prints out J is 1, just like that. And then it's going to increment J, and now J is equal to 2, so we jump out of the 4, and we go back up to the top. Now I is equal to 2, I is equal to 2, gets printed. Then we do this again with the J. It's equal to 0, incremented to 1, it's equal to 1, incremented to 2, we skip out. Increment I up here. I is now equal to 3. Those two equal, and the program ends. And that's your output. So that is the entrance into nested loops. Now, I'm going to give you some caveats, warnings, whatever you want to call it. Nested loops run slower by nature. Okay? They just do. There are better ways to do things if you're looking for data that's in a data set or in a file or anything like that. There's better ways to go about it. If you're pulling data from a database, you should be building a better query to get that data out of that database. If you're bringing back all the data from a database or a file, then what you're doing is you're bringing this all into memory, and then you're going to have to go through it with for loops. Hopefully not nested for loops. But if you're doing nested work, you might want to look at what you're actually doing. Thanks for watching the video. Please like and subscribe to the channel. I really hope you liked the video, and I hope you understand how loops work now. There is one more loop. It's called a for each, but I'm not going to talk about that until we talk about generics. The next two videos are about the most popular way that memory is used, and that's referenced memory. So who was credited with the first loop? That would be Ada Lovelace. In 1812, she was an English mathematician who worked with Charles Babbage. She was working on Bernoulli numbers, and she needed a way to restart her process again, to kick it back off. Charles Babbage had already created machines that could process and perform calculations. Sort of like a calculator, but only like basic addition and basic subtraction. Ada had a job as a computer, and that sounds kind of funny today, but that's what people were called that did these calculations and were mathematicians. They were called computers, and eventually they were replaced with machines, and the best word at the time that they could come up with was computer. Ada needed a feedback loop to restart her calculation over and over again. Now, I'm not thinking this was actually like a program feedback loop. I think it was a wired feedback loop from electronics. Technically, she was the first person to create an infinite loop. The feedback loop just kept running and running until they shut it down. one of the first general purpose programming languages that was based on Pascal was named after her. It's called Ada. It's one of the first languages that I coded in. It was written for the Department of Defense in 1977, and when Ada started being used by the DoD, it replaced over 450 specific task programming languages. So what people used to do is they would write a small language of just little functions, modules, whatever, and they would call into them, and it would basically just go out and perform a task. It wasn't something that was real general like you know on languages today, like C#. Languages today are what used to be called general languages, and Ada was one of the first ones. You're always welcome back here at the C# workshop, and have a nice day.